Today we're going to be working with TEK 5.3H, which is represent and solve addition and subtraction of fractions with unequal denominators, referring to the same whole using objects and pictorial models and properties of operations. So basically what we're going to be doing today is working with adding fractions that have different denominators using the area model, and then we're also going to use a linear model. So you'll have two different ways to do it. So first we're going to talk about a fraction. So say I have 4 over 6. So this means that 6 is the whole number, and 4 is a part of the whole. So when we are adding our fractions together, there's some misconceptions we need to go over. So say you have 2 over 6 plus 1 over 6. So your natural instinct would just be to add straight across, which is what you do for the numerator. So 2 plus 1 is 3. But then for the denominator, you're just going to leave it exactly the same and leave it as 6. So your answer would be 3 over 6. And so the reason we do that is, say you're having a bake sale and you make 6 brownies. So each box that I draw is going to represent a brownie. And so now let's say that on the first day you sell 1. And then on the second day you sell 2. And you want to know how many brownies you sold altogether on the 2 days. So your equation is going to be 1 over 6 plus your 2 over 6 from the second day. So when we add our numerators across, again we get our 3. And then on the bottom, if we added our 6 plus 6, we would get 12, which can't be correct because if we look up here, we can see we only have 1, 2, 3, 4, 5, 6 boxes. So there's no way possible for us to have 12 brownies when we only started off with 6. So make sure you always keep that in mind when we're adding. And then the last thing I want to talk about is that the adding fractions follows the same property as the commutative property of addition. And so that means that 1 over 6 plus 2 over 6 is going to equal the same thing as 2 over 6 plus 1 over 6. So it doesn't matter which way you add them. Either way, you're still going to get the same answer, just like in regular addition. So now we're going to get started with our word problems. And so today the first one we're going to use is the area model. So our word problem says that Kate and John decided to each order a pizza after a long day at school. Kate ate 2/4 of her pizza and John ate 4/8 of his. Altogether, how much of the pizzas did they eat? So let's draw out our equation. So Kate had 2/4 plus John's 4/8. And now we can see that to add, we need to have common denominators, and we don't here. So we're going to need to figure that out. So to do that, we're going to use our area model, and I've made little pizzas to help us represent our word problem. And so we're going to draw it out. So we put our 2/4 to represent Kate. And then here I'm going to put our 4 out of 8 pieces for John. And if we look, we can see that they look like they're both about equal, right? So we think they're going to equal the same thing. So when we make our common denominators, we're going to times 2 so that it'll equal 8. So we also need to times 2 to our numerator. So we're going to get 4 over 8 plus our 4 over 8 that we already had. So we can see that these fractions are actually the same. So when we add straight across, remember we add our numerators, so we get 8. And then we don't add our denominators, so we also get 8. So we get 8 out of 8, which when we simplify is going to equal 1 whole, because 8 divided by 8 is 1. So now if we look down back here, to check our work, we can use our area model and see that when we put our 2/4 plus our 4/8, it does equal our 1 whole of our pizza. It fills it all up perfectly. So now we're going to talk about the linear model, and we're still going to use our same numbers, but just a little bit of a different problem that deals with length. So this problem says Kate and John were training for a marathon. Kate ran 2/4 of a mile. John ran 4/8 of a mile. How far did they all run together? So we have our 2/4 that Kate ran plus our 4/8 that John ran. And now we're going to use some linear rods. And so our 1 hole is going to be our base that we're going to refer to. So it's 1 hole, or we can think of it as 1 mile. And then we have our 2/4 from Kate and our 4/8 from John. So if we look at this, we can see that they're both equal to each other, which we learned from our last problem. And so if we put it over here, we can see that they're both going to equal the 1 whole mile because it lines up perfectly. So this is going to equal, like we said again, if we add it, we would have to make our denominators common. So we'd have 4/8 plus 4/8. And again, we get 8/8, which is equal to our 1 whole that we see down here. And that's the linear model.